thermal or internal store. This is the energy store associated with an object's temperature. Now we have an equation for this. We have ET, which means energy thermal, is equal to mc delta theta, where m is the mass of the object, c is the specific heat capacity, which is a property that varies between different materials, and delta theta means change in temperature, where delta is change in and theta is temperature. So let's look at how the energy depends on each of these quantities. We'll start with mass. If one object has more mass than another object, that means more energy can be stored in its thermal store. So if we have that the mass 1 is smaller than mass 2, then mass 1 will be able to store less energy in the thermal store than mass 2. You can consider a pair of kettles, one which is full and one which is half full. The one which is half full will boil more quickly because it requires less energy to increase its temperature. That is because it has a smaller thermal store. You can also consider a sparkler and a bucket of water. The sparkler may be burning at 5,000 degrees, and the bucket of water may only be around 20 degrees. However, there's more energy in the thermal store of that bucket of water because there is significantly more mass than in the sparkler. You can see this by simply taking water that is at 15 degrees and plunging a red-hot sparkler into it. You will notice that the water does not significantly increase in temperature. This is because it requires a lot of energy to increase its temperature because there's more mass there. Next, specific heat capacity. This property varies from material to material. So the example we have here is on the left we have gold, and on the right we have water. Now there may be more atoms in the gold, and it may have more mass. However, gold cannot store as much energy in its thermal store as water can. So what we have is C1 is less than C2. So the specific heat capacity of gold is less than the specific heat capacity of water, which means the energy stored in the thermal store in gold will be less than the energy stored in the thermal store of water. Finally, we have temperature, and for that we will be using a PhET animation, which can be found at phet.colorado.edu. So let's look at how the energy in the thermal store depends on temperature. So what we have on screen is a solid material made of atoms contained inside a cylinder. We know it's a solid because the atoms are in fixed positions. Now currently it is at a temperature known as absolute zero. This is the theoretical minimum temperature of the universe. Now let's look at what happens when we heat this object. Very quickly you notice that the atoms begin to vibrate. They begin to move about. Now this is still a solid because the atoms are still in fixed positions, but the atoms are now vibrating and colliding with one another. This is also how energy is conducted along a material by heating. What happens is if you heat the atoms at the bottom, they will then collide with the adjacent atoms, passing that energy along. So you'll notice now that we've increased the temperature of the object, what it means is the atoms themselves are moving about. If we further heat the object, you'll notice that the atoms move more. So there is now more energy in its thermal store. And if we further heat it, we can in fact break the bonds that are holding the solid together, and this will result in the material going from a solid to a liquid, where the atoms are no longer vibrating about fixed positions. They are able to freely flow past one another.